Today on Capechi's Corner, we're going to look at solving quadratic equations by factoring. So we factored in previous lessons. Today we're going to solve. So in number 1, I do not have a greatest common factor. I'm going to set up my two parentheses, set it equal to 0. X squared is going to give me x and x. Signs are the same. They're both in negative. Factors of 12 that when I add together, I'll get 8. So that gives me 6 and 2. Now, because of the zero product property rule, when I multiply and I get a 0, one of these binomials has to equal 0. So I'm going to do that step. X minus 6 is equal to 0. X minus 2 is equal to 0. So x is either equal to 6 or x is equal to 2. Now, you can always double check your work by plugging these answers back into your original equation. Number 2, same thing. No greatest common factor. X and x, signs are the same. They're both a plus. Factors of 64, when I add together, I get 16 is 8 and 8. Now, in this case, I have the same binomial. I don't need to write that twice. Just once is fine. So my final answer there is x is equal to negative 8. Looking at number 3, I do have a greatest common factor here. My greatest common factor is 8x. So I have 2x plus 1 is equal to 0. Remember, if I start with a binomial, in my parentheses, I have to have a binomial, right? So at this point, I have either 8x is equal to 0 or 2x plus 1 is equal to 0. So x is either equal to 0 or x is equal to negative 1/2. In number 4, in this case, I have to set everything equal to 0 first if I'm going to factor. So I have x squared minus 64 is equal to 0. I have a perfect square minus a perfect square. So I have x plus 8 and x minus 8. So x plus 8 is equal to 0, or x minus 8 is equal to 0. So x is either equal to negative 8 or x is equal to positive 8. And number 5, again, we have to look at our greatest common factor. So I have 6a to the 4th, and I'm left with a plus 3 is equal to 0. So either 6a to the 4th is equal to 0, or a plus 3 is equal to 0. So either a is equal to 0 or a is equal to negative 3. All right, let's look at our last one like this. So again, I have to put everything to one side. My coefficient here is negative, so I want that to be positive because that's my highest power. So I want my leading coefficient to be positive. So I'll bring that to the other side, rewrite, set up my parentheses. Now, I know that 15 could be 15 and 1 or 5 and 3. I don't know which one yet, so I'm going to hold off on that. My signs are the same. They're both in negative. I like to put those in. And 1 can only be factors of 1 or only 1 and 1. So I'd like to put in what I know so far. So I need factors of 15 now that work in a combination of 1 that's going to get me to 8. So that's actually 5 and 3. So 5x goes here, 3x goes here. So I either have 5x minus 1 is equal to 0 or 3x minus 1 is equal to 0. So x is either equal to 1/5 or x is equal to 1/3. Now, one thing to tie things together, when we're talking about quadratic equations, the solutions are actually the x-intercepts of the graph. You see sometimes that they call the x-intercepts the roots. So if I were to have two solutions, like most of our equations did in the previous examples, it means that I'm touching the x-axis somewhere in which it's hitting twice. It could also be open down and hit twice. Doesn't matter as long as it's crossing that x-axis twice. Now, if I have one solution, it's only touching that x-axis one time. Same thing, I could go down somewhere as well, hitting it one time. Now, if we had a quadratic equation in which there's no solution, it means that it's not going to touch that x-axis. So again, it'll open up somewhere like that, or again, it could open down, doesn't matter as long as it is not touching the x-axis. Okay, looking at our last type of problem for today, it says write a quadratic equation in standard form with negative 1/3 and 6 as its roots. Now remember, roots is where it crosses the x-axis. It's also the solution. So let's think about how we got there on previous problems. So if I had x minus 6 as one of my binomials, I would set x minus 6 is equal to 0 and x would equal to 6. So that's what we have there. So we're basically working backwards. So how would I get that x is equal to negative 1/3? Well, I would have to be positive. And remember, 3x plus 1 is 0. So x is equal to negative 1/3, which is what we started with. So that's how we're basically working backwards. So let me get rid of all of this because the directions are asking for to write a quadratic equation in standard form. So now I have to use FOIL, or you could distribute. And so I have 3x squared minus 18x plus x minus 6 is equal to 0. So 3x squared minus 17x minus 6 is equal to 0. So that's the quadratic equation we want in standard form. All right, let's look at our last one for today. Again, I'm going to set up my parentheses. I know I have a positive 3/4, so I'm going to have a negative in there. So this is going to give me 4x minus 3, and it's going to give me x plus 5. Use FOIL. I have 4x squared. My outside is plus 20x. My inside is minus 3x. My last is minus 15 is equal to 0. Combine my like terms, and I have 4x squared plus 17x minus 15 is equal to 0. So that is my quadratic equation in standard form. Okay, great job today. Have a good one.